All right, welcome back to AP Pre-Calc. This is day 2 of lesson 1.11. Today we are going to talk about Pascal's triangle and the binomial theorem. So Pascal's triangle and the binomial theorem go pretty much hand in hand. Remember, a binomial means there are two terms, right? And a lot of times we'll have a binomial raised to a power, and we want to expand that. And without Pascal's triangle and or the binomial theorem, all we can do is a whole bunch of foiling, right? So I could do like this first one. I know I could FOIL that, and we could get x squared plus 6x plus 9. Well, for the next one, I would have to take that and multiply again to get the next one out. And I get x to the third plus 9x. Now, I'm doing a lot of this behind the scenes, so 27x plus 27, okay? And like you could do that, but if I go up to x to the binomial to the fourth or binomial to the fifth, now it's getting a little out of hand. So there's got to be a better way to do that. So I'm going to show you what Pascal's triangle is. You might have seen this before. And there's a pattern to this thing, right? If you haven't noticed the pattern yet, I'm taking the two above it and I'm adding. So you guys could probably figure out the next one. And once you know the pattern, it's real easy to figure out. Well, what these things are the coefficients of each term. I'm going to do this with x plus y. I think it might look a little bit easier. If I do x plus y, we get 1. So it matches up. If I do x plus y to the first, I'm going to get x plus y. Well, there's a 1 there, and there's a 1 there. If I do x plus y squared, I'm going to get x squared plus xy plus y squared. And there's actually 2 of those xy's. And there's one of those, and there's one of those. So the coefficients will match up to Pascal's triangle. So without even doing the next one, without putting x plus y to the third, I know it's 1x to the third plus 3x squared y plus 3x y squared plus y to the third. I got the same coefficients as Pascal's triangle, and look what's going on with the exponents. They always add up to 3. They have to add up to whatever the degree is you're raising the binomial to. And your first term starts with the biggest exponent and works its way down to 0, because if you look in that last one, there's x to the 0 power. We just don't put it there because it's a 1. And then your second one starts with none, and it works its way up to, in this case, 3. Pascal's triangle can get a little cumbersome, so we have this thing called the binomial theorem. We use it quite a bit in AP statistics. You use it in physics. You use it in, I believe, chemistry and biology. It's just used a lot. So the first thing that you might not recognize is this. And a lot of times you'll see it written like that. And all that is this from last year. And that's your combination. This tells you how many you get to choose from. This is telling you how many you're choosing, okay? So go ahead and look at this one. The first one, we start out with a 0 in the denominator, right? And this thing right here is going to be the exponent that goes with your second term, okay? So let's look across all these. So I have a to the n. That means I have all of the exponent here, and the second term gets none of them. This one has the exponent minus 1, but the second term has a 1. So these two things will always add up to whatever your exponent is, okay? It'll be a little bit easier when we throw some regular numbers in there. I know it's this is just a really mathy way to show something, so I don't really want you to get too concerned about this because it's not as hard as you think it is. So if I'm looking for the coefficient of a certain number in a binomial expansion, we could use either Pascal's triangle. It's just that you'd have to write them down, or you could use the binomial theorem, okay? So like this one right here, we know that's going to be something to the 5th power. Well, that first one would be that this is n over 0, right? The next one would be n over 1, so on and so forth. And we can use our calculators to figure out these numbers. You don't have to do it. We'll show you all of that in a little bit, okay? But it's pretty easy to use. What I do want you to know is that there's always one more term than your exponent. So if I have x plus 7 raised to the 10th, there's going to be 11 terms in that expansion. The first term, the x will be to the 10th, and it'll go down by 1 until it's to 0, right? So if there was only 10 terms, your last term would have an x in it, and you would not have a constant. Your last term is always going to be, the x to the 0 power, and your second term, whatever that is, like in this case, 7 to the 10th power. Okay. All right, so here again, notice that this 5, 2 corresponds with that number right there, because this one would be 5, 0, this would be 5, 1, the third one would be 5, 2, okay? And that would give you the coefficient that would go with that term. It doesn't mean that is the ending of the coefficient, it's just that there's a little bit more work to do. This is the notation that we learned last year for the combination. We didn't see this before. That's the new stuff from this year, but we have done that formula. And if you remember, we really just used our calculator, because if we go to probability, the NCR is right there, and it's really easy to put it into our calculator. So again, don't really worry too much about that formula. I don't think we need to know it for the test, but we have to know how to use our calculator. All right, so example 10, we have this, and we want to expand using Pascal's triangle. So what I'm going to do is quickly write down Pascal's triangle. So give me a second. All right, there's Pascal's triangle. Notice that it has a nice symmetry to it. You go up and then back down. So I want to expand the whole thing. So I know my first one will have 1, the first term to the 5th, the second term to 0. Right? You don't have to put that one. I'm just putting it there to show you that it is there. We just don't need it. And then the next one, put the coefficient, the first term to the 4th, the second term to the 1st, because they have to add up to 5. All right, and I'm going to go ahead and write the rest of these. Give me a second. Okay, there it is, all written out. We have to clean it up a little bit, because you shouldn't have these 2 to the 3rd, 2 squared. Those are actual numbers, and you take that, whatever that value is, and multiply it by the coefficient. So I'm going to pause the video again, and I'm going to write it all in, and I'll start it back up. Okay, there is our expansion of x plus 2 to the 5th. Now notice the coefficients of the answer don't match the coefficients of Pascal's triangle, but Pascal's triangle is not the coefficients of the answer. It's the coefficients of the terms before you simplify them. If that was x plus y to the 5th, then we would see the exact coefficients from Pascal's triangle. But you can see right here, those are the coefficients that we use. It just so happened that we had more numbers in there that caused a change in the actual final answer. All right, let's do it again. I'm going to pause and write down my Pascal's triangle. Why don't you guys pause and see if you can get it before me. All right, there it is all written out. You can see the 1, 4, 6, 4, 1, but I do have other numbers going on there, so I'm going to have to clean this up a little bit. Give me a second. All right, there it is all cleaned up. Notice that we have sign changes throughout this. When one of your terms inside the binomial is positive and the other one is negative, it'll always flip-flop back and forth. You'll never get 2 positives in a row. You'll never get 2 negatives in a row. It'll always go positive, negative, positive, negative, positive, negative. Okay. All right. So here we have a little bit different way to ask a question. But you know what I'm going to do? I'm going to go ahead and use the binomial idea and not Pascal's triangle on this one. So I'm looking for the term that will have x to the 4th, which means the second one, the 5, has got to be squared. And if you remember this guy right here, The bottom number is the exponent that goes with the second term, and the top number is the degree of the whole thing, which is 6. So I can take my calculator and do 6 combination 2 and come up with that number, and that would be 15. The x to the fourth is just x to the fourth, and the 5 squared is 25. So I got to clean that up a little bit. I got to do 15 times 25, right? And that would give me 375 x to the fourth, right? So the coefficient is 375. The coefficient isn't the 15 because we had that extra number in there. It was 15 in Pascal's triangle, but it's not the end coefficient. Let's look at 13. What is the coefficient with the term containing x to the third? Why don't you pause the video and give it a shot? All right, hopefully you have this written down. I put x to the third, which means the second term has to make up the other to make 8, so that's a negative 3 to the fifth. I put my little binomial symbology out here. I throw it into my calculator, and I get 56. And that gives me x cubed, and then whatever negative 3 to the fifth is. I think it's negative 243, if I'm not mistaken. And I multiply that by negative 243, and I get negative 13,608 as my coefficient. If you want to, you put x to the third right there. All right, there we go.